All right, we are doing some more testing for parallelograms. For these first problems, we want to show that they should be parallelograms. So if these are parallelograms for our first problem here, what do we need to know about them? Well, we know to have a parallelogram, we have to have both sets of sides, both sets of opposite sides, need to be congruent. Okay, that's one way that we know that we have a parallelogram. So if to show that both sets of our opposite sides are congruent, we could put our congruent marks on our opposite sides and then create our equation. So we see that 2x minus 2 should equal 12. Solve this. So we would add 2 to both sides. 2x is then equal to 14. And to solve for x, we would divide by 2. So x would have to be 7. For our other equation, we see that 2y should equal 8. Solve it. We just have to divide by 2. So y is equal to 4. Okay, so let's look at our next example. Our next example has angle measures. In order for us to be a parallelogram, we know that both pairs of opposite angles need to be congruent. And if they are, it is a parallelogram. So when we take a look, we only have 3 angle measures, but we do know that our opposite ones have to be congruent. So here we know that 11x has to equal 55. Well, if 11x equals 55, divide both sides by 11, x should be 5. Something else we know about parallelograms is the consecutive angles, they should add to equal 180. So 5y plus 55 should equal 180. And now we just need to solve this for y. So we can solve this for y by first subtracting 55 from both sides. So 5y is equal to 180 minus 55 is 125. And then we can divide both sides by 5. So y is equal to 25. Okay, we're going to do a couple more examples. Next one up, we have this diagram. We want to make sure that this is a parallelogram. So we know parallelograms, opposite sides should be equal. So we can say 6y should equal 18. Divide both sides by 6, so y is equal to 3. These angles now are a little bit trickier, but if we do have a parallelogram, that means that we have these sides are parallel, which tells us something about 45 and the 9x. They are alternate exterior angles, so alternate interior angles, so they would have to be equal as well. So we'd make 9x equal to 45, divide both sides by 9, so x here would have to be 5. And one more example with our parallelograms here. Once again, we're going to use the idea of alternate exterior or alternate interior. So we see here that 2x should have to equal 30. So we can divide by 2 and x is 15. The other way, we see that x plus y should equal 24. Oh no, but that has 2 variables in. Well, we just found out that x was 15, so we can plug 15 in for our x and then solve for our y. So to get y alone, we would have to subtract 15 from both sides. So y is equal to 9. All right, so now we are going to find, we want to decide whether or not this is a parallelogram. And we are going to use the slope formula. So the slope formula, we have to find the slope of the opposite sides and see if they are parallel, so see if they are the same. So our A is at 0, 0. Our B is at 1, 3. Our C is at 5, 3. And D is at 4, 0. We can find the slope by counting it, or you can use the slope formula, which is y2 minus y1 over x2 minus x1. We're going to count. So from A to D, rise over run, we do not rise at all. So it has a rise of 0, and we went over 4. 0 over 4 simplified is 0. AD, the side opposite to AD, is BC. The slope from B to C, so rise over run, we did not rise at all, so 0. We went over 4. Simplified down is 0. So our first set of opposite sides are equal. So far we're looking like we could have a parallelogram. A to B. Our rise, 1, 2, 3. We went over 1. So it's 3 over 1 for the slope, reduced down to just 3. Slope from C to D. We rise 1, 2, 3 over 1, which reduces down to 3. 3 and 3 are also the same. So since we have AD is parallel to BC and AB is parallel to CD, ABCD is a parallelogram. When you are doing problems like this, you need the justification. The justification is right here in your work, showing that you found the slope, and your justification is also writing down which sides ended up being parallel to one another. All right, here's another example about this. Here we have S is at negative 2, 4, T is at negative 1, negative 1, U is at 3, negative 4, and V is at 2, 1. We want to use the distance and the slope formula. So I'm first going to graph these. So there's S at negative 2, 4. T is at negative 1, negative 1. U is at 3, negative 4. And V is at 2, 1. So now, this is a sketch of a graph, so if you use actual graph paper, you'd have a better idea. This doesn't really look like a parallelogram, but we are certainly going to check to see if it is one. So if this is a parallelogram, the distance and slope of one set of opposite sides are equal. So we have to decide which opposite sides we want to work with. So we can look at ST and VU. So for ST and VU, they are opposite of each other. We want to see if they have the same slope, and then if they have the same distance. I'm going to actually use the slope formula for this one, mostly because the sketch in my graph looks pretty terrible. So I'll do the slope formula to make sure that we are doing it correctly. So ST, y2 minus y1, so negative 1 minus 4, over x2 minus x1, negative 1 minus negative 2. Negative 1 minus 4 is negative 5. Negative 1 minus negative 2, we add the opposite, is positive 1. So that has a slope of negative 5. Now do the same for VU. In your slope formula, I'll write it over here. y2 minus y1. So V to U, 1 minus negative 4 over x2 minus x1, 2 minus 3. 1 minus negative 4, so we add the opposite, becomes 5 over 2 minus 3 is negative 1, so that's negative 5. So far, So good. We've shown that their slopes are indeed equal to each other. Now we have to show that they have the same distance. So distance formula. Your change of x squared plus your change of y squared. Or you can look at the x2 minus x1 squared plus y2 minus y1 squared. So from s to t, our change of x from -2 to -1 is 1, so 1 squared. Plus our change of y from 4 to -1 is 5, so 5 squared. 1 squared is 1, 5 squared is 25. 1 plus 25 is 26. So the distance from s to t is the square root of 26. V to u, the distance. Change of x squared. 3 to 2 has a change of 1, so 1 squared. Plus change of y squared. 1 to -4 has a change of 5, so 5 squared. 1 squared is 1. 5 squared is 25. 1 plus 25 is the square root of 26. So are those distances equal to each other? Yes, they are. They're both the square root of 26. So ST is parallel to VU, and ST is congruent to VU. Because it is parallel and congruent, STUV is a parallelogram. Okay, so that's how we're going to do the distance and slope ones. We'll do one more of this type together. F, G, H, I, we want to use the midpoint formula. So I will once again sketch this. Hopefully a better one than last time. So here's point F at 3, 3. There's G at 1, 2. There's H at -3, 1. And I at -1, 4. So, according to my diagram, this does not look too promising if this is a parallelogram. But since I sketched the graph, I could have done a poor job of it. So we're going to check this using the midpoint formula. Our midpoint formula is x1 plus x2 divided by 2 and y1 plus y2 divided by 2. And we do the midpoint of our diagonals. So one of our diagonals is IG and the other one is FH. IG, FH. So from I to G, -1 plus 1 divided by 2 for our x's. Y2 plus y1, so 4 plus 2 divided by 2. -1 plus 1 is 0, so 0 divided by 2 is 0. 4 plus 2 is 6. 6 divided by 2 is 3. So the midpoint of IG is at 0, 3. FH. x1 plus x2, so 3 plus -3 divided by 2. H is 3 plus 4 divided by 2. 3 plus -3 is 0. 0 divided by 2 is 0. Okay, so far we have the same x point. 3 plus 4 is 7. 7 divided by 2, though, is 3.5. So right there, are those the same exact point? No, they're not. One has a y value of 3, and the other has a y value of 3.5. So here's your justification right here. And so because of this, FGHI is not a parallelogram. Their midpoints are not the same. Okay? Hopefully after this it has refreshed you a little bit as to what we were talking about with the test of parallelograms, which you learned on Friday. At this time, you are going to have the worksheet 8.3 handed out to you. All of them are assigned and they are due tomorrow, Tuesday. Tomorrow we will have a review on sections 8.1 through 8.3, and I will be able to go through any questions you have.